So this video is on the factor theorem. The factor theorem is that for the polynomial f of x, we talked about in the algebraic division video what a polynomial is. A polynomial is an algebraic expression with positive integer indices. Basically, all of the algebraic expressions that you've met so far are polynomials. So quadratics, cubics, quartics are all polynomials. For the polynomial f of x, if f of b over a is equal to 0, that means that we sub in the fraction b over a for all of the values of x. If this gives out the value of 0, then ax minus b is a factor of f of x. So let's do some examples of this. So let's say that f of x is equal to x cubed minus 5x squared plus 2x plus 8. Well, if we do f of 4, this means that we sub in 4 for all the values of x. This is going to be equal to 4 cubed minus 4 squared plus 4 plus 8. And if we put this into a calculator, this is equal to 0. So therefore, I'm going to use these kind of 3 dots here, kind of like in a triangle like this. This is kind of a shorthand way of saying therefore. You can ignore it if you want. You don't even have to write it if you don't want to. Therefore, x minus 4 is a factor of f of x. X minus 4 is a factor of f of x, which is x cubed minus 5x squared plus 2x plus 8. The reason it's x minus 4 is, remember that 4 is technically 4 over 1, and this is the fraction here where b is 4 and a is 1, and then we sub it into this here in order to get x minus 4 as the factor. Let's do another example. Let's say that g of x is equal to 3x cubed minus 2x squared minus 3x plus 2. Well, g of 2 over 3 is equal to 3 of 2 over 3 cubed minus 2 of 2 over 3 squared minus 3 of 2 over 3 plus 2, and if you put this into a calculator, this is equal to 0. So therefore, 3x minus 2 is a factor of g of x, again because it is the fraction 2 over 3, so b is equal to 2 and 3 is equal to a, and then you sub it into this formula up here. Let's do one more example. Let's say that h of x, let's do a quartic this time. Let's say that h of x is equal to x to the power of 4 plus 6x cubed plus 3x squared minus 26x minus 24. If we do h of minus 3, this is going to be equal to minus 3 to the power of 4 plus 6 minus 3 cubed plus 3 minus 3 squared minus 26 minus 3 minus 24, and if you put this into a calculator, this is equal to 0. So therefore, x plus 3 is a factor of h of x. It is going to be plus 3 this time because b is equal to minus 3, so therefore there's a minus here as well, so the sign is going to be flipped this time and it's going to be a plus. So what do we actually mean when we say that ax minus b is a factor of f of x? Well, what it actually means is that if we fully factorize f of x, one of the brackets will be ax minus b. So let's do this for g of x, and I want to show what this means. So g of x is 3x cubed minus 2x squared minus 3x plus 2. If we fully factorise g of x, because we know that 3x minus 2 is a factor of g of x, if we fully factorise g of x, it is going to be 3x minus 2, and then because it's a cubic, there's going to be two other brackets. We're just going to call these ax plus b and cx plus d, because we don't know what these are, but we know that one of the brackets is going to be 3x minus 2, because we figured out before that 3x minus 2 is one of the factors of g of x. And as you might be able to see, because there are three brackets, there are going to be three factors, and therefore there are only going to be three values of x that you can sub in order to get 0 out as when you put it into g of x. There are only three values for which it works for the factor theorem. We can find what these two factors and what these two brackets are by experimenting and trial and error and seeing what values work by subbing them in as x, and and seeing if they get 0 out as the answer. And another way that you could actually find these two brackets is by using algebraic division, which we went over in the algebraic division video and we'll go over again in this video. So the reason the factor theorem actually works is actually really simple, and basically what you're just doing is finding the solutions for when f of x is equal to 0. So let's show why this is for g of x. So the values that you sub in, the three values that you can sub in for x in order to get 0 out for g of x, the three values are going to be 2 over 3, we've already established this here, and the other two values are going to be 1 and minus 1. You can figure this out if you do enough trial and error and experimenting, that they're going to be 1 and minus 1. You can sub these in if you want. You can sub 1 and minus 1 in as values of x, and you will be able to see using your calculator that it does give out values of 0. These are the three values that you sub in to get 0 out. So therefore we can say that the three factors of g of x are going to be 3x minus 2, which is the one we've already established, and the other two factors are going to be, for 1, it's going to be x minus 1. You can do this by, remember 1 is 1 over 1 technically, so therefore you can sub this into the formula for b over a, where both b and a are 1, so it's going to be x minus 1, and then the other factor for minus 1 is going to be x plus 1. So these are the three factors, and therefore we can fully factorise g of x. We can fully factorise it as 3x minus 2, and we found what the other two factors are and what the other two brackets are, so we can say it's 3x minus 2, x minus 1, x plus 1. Now what if we equal g of x to 0, and we want to find the solutions of x which make g of x equal to 0? Well, the way we can do this is we can find when the individual brackets here are equal to 0, so all the brackets are times together. So if one of the brackets is equal to 0, then the whole thing is therefore going to be equal to 0, as we're timesing them all together. The whole g of x is going to be equal to 0. We've already gone through this. So the values of x are going to be when this bracket is equal to 0, so 3x minus 2 is equal to 0, when this bracket is equal to 0, so when x minus 1 is equal to 0, and when this bracket is equal to 0, so x plus 1 is equal to 0. We can rearrange in order to find the value of x, so this is going to be 3x is equal to 2, and then it's going to be x is equal to 2 over 3. This is going to be x minus 1. If we rearrange, it's going to be x is equal to 1, and if we rearrange this, this is equal to x is equal to minus 1. So we've got 2 over 3, 1 and minus 1 as the values of x, and as you can see, these are the exact same values that we got up here for the values we subbed in as x in order to get g of x equal to 0. And this makes perfect sense because we have done the exact same thing in both cases. We've just done it in two different ways. Down here we did it algebraically by finding the values of x algebraically, and then up here we subbed in the values of x to see which ones gave out g of x equal to 0. In both cases we have actually done the exact same thing, and this is actually how we get out this formula up here, ax minus b. This is actually just the reverse process of doing this to find this factor 3x minus 2 from 2 over 3. This is actually how we get this formula. So why am I telling you this? Well, the reason is because I hate remembering formulas, and I never use this at A level. I never use this ax minus b kind of formula. I never subbed it in because I hated remembering formulas. I was really bad at it. Instead, I remembered this relationship of how it worked, and I just remembered that instead it is the reverse process of this process here of putting the 3x minus 2 equals 0 and finding the value of x. It's the reverse process of doing this, so I actually just quickly did this in my head logically rather than remembering this formula. So if I was in the exam and I got 2 over 3 as equal to 0, I got 2 over 3 as equal to 0. So that is the value. Well, instead of using this formula, what I would do is I would just do reverse of this process here, and I would make one of the sides equal to 0, and I would move everything onto one side. So I would say that x is equal to 2 over 3, so then times both sides by 3, so 3x is equal to 2, and then move the 2 onto the other side, so 3x minus 2 is equal to 0. And this here is the factor that we would get from using the formula, and I much prefer doing it this way, as you can just really quickly in about 2 seconds, once you do it enough, just do this really quick in your head. And I would much rather do this method than remembering this formula here and subbing in the values. I find this a lot more easier to use. We talked about this method already in the factorising video in the algebraic expressions chapter. So this here is a really common exam question that they could definitely ask you. So part A is a really typical factor theorem question. Now usually factor theorem questions are only 1 mark. They're really simple, and the reason is because they are literally just really simple. All you're doing is just subbing in a value. So if we need to show that 3x plus 5 is a factor of this, therefore we need to sub in the value minus 5 over 3. Again, you can figure this out easily just by using the formula if you want, or by doing the method as I said before, by doing 3x plus 5 is equal to 0, and then just making x a subject. So it's going to be 3x is equal to minus 5, then x is equal to minus 5 over 3. So therefore we need to sub in this value, and then as we need to show that 3x plus 5 is a factor, we are expecting this to be 0. So what we can do is we can do 3 of minus 5 over 3 cubed minus 4 minus 5 over 3 squared minus 45 minus 5 over 3 minus 50. You have to show this part here in order to get the mark, in order to show that you actually understand that you need to sub this value in. And if you put this into a calculator, this will indeed give out the value of 0. So therefore you should always write a sentence at the end of factor theorem questions in order to show show that you understand it. It's sort of like a proof in a way. You should always write a sentence at the end. So therefore, as we've subbed in this and it's equal to 0, therefore 3x plus 5 is a factor of 3x cubed minus 4x squared minus 45x minus 50. And you can see why this is only 1 mark, because all you're doing is just subbing in a value into a calculator and proving that it's equal to 0. It's a very easy mark to get. I was talking in the algebraic division video about what a typical algebraic division question will actually look like, and it will look like something like part B. And what this question actually wants you to do is it wants you to divide 3x cubed minus 4x squared minus 45x minus 50, and it wants you to divide it by 3x plus 5, and this will allow you to find these other 2 brackets. The way you can do this is because 3x cubed minus 4x squared minus 45x minus 50 divided by 3x plus 5 will give you a quadratic, and we'll just call this quadratic cx squared plus dx plus e. Well, if you times both sides here by 3x plus 5, this is going to give you 3x cubed minus 4x squared minus 45x minus 50. The denominator is going to cancel out. And on this side is going to be 3x plus 5 cx squared plus dx plus e. And as you can see, this is the factorised form of f of x. The only difference is here we've got two brackets, but here we've got a quadratic. And the way we can just easily just solve this is just by factorising this quadratic here, which will just be equal to 3x plus 5, and then we factorise the quadratic into two brackets, and this is going to be the x plus a, x plus b. And this is why we do the algebraic division, is so we can find this quadratic and then we can factorise it in order to find these two brackets here. So now let's actually do the algebraic division. If you don't know how to do algebraic division, then you'll have to watch the algebraic division video. But basically what you do is you do the 3x plus 5 out here. Then on the inside it would be the 3x cubed minus 4x squared minus 45x minus 50. So the first thing we need to do is we need to divide 3x cubed by 3x, and if you do this, this is going to be x squared, and we're going to write this up here. Then we need to times the x squared by the 3x plus 5, and this is going to be 3x cubed plus 5x squared. Then we're going to minus this. These two are just going to cancel out, and remember we need to include this minus at the start as well, so this is technically brackets, so it's going to be minus 4x squared minus 5x squared, which is going to be equal to minus 9x squared, and then we're going to bring the minus 45x down here. Then we need to divide the minus 9x squared by the 3x, and this is going to be minus 3x. Then we need to times the minus 3x by the 3x plus 5. We're going to write this down here, and this is going to be equal to minus 9x squared minus 15x. Then we need to minus these two are just going to cancel out. Then it's going to be minus 45x, remember to include the minus over here, so it's going to be minus 45x minus minus 15x, which is going to be minus 45x plus 15x, which is therefore going to be minus 30x, and then we bring the minus 50 down here, and then we divide the minus 30x by the 3x to get minus 10. Then we're going to times the minus 10 by the 3x plus 5 to get minus 30x minus 50, and then we're going to minus these two are just going to cancel out. Then it's going to be minus 50 minus minus 50, which is going to be minus 50 plus 50, and this is going to be 0. Now, a good way to check if you've done the algebraic division right is, as you know that 3x plus 5 is a factor of 3x cubed minus 4x squared minus 45x minus 50. We did this in part A. Therefore, you know that the remainder has to be 0. So as we've got the remainder 0 here, therefore that is an indication that we have done the algebraic division right. That's really useful, and it allows us to tell that we've done it right. That's a really useful tip, in my opinion, is to check the remainder, and that's a good way to check if you've done algebraic division right. Okay, and then we can write it in this form here, using the answer up here to do 3x plus 5 x squared minus 3x minus 10 from up here, and then we can just factorize the quadratic into these two brackets here, and this is going to be equal to 3x plus 5, and then the factorized quadratic is going to be x minus 5 x plus 2, because if you times minus 5 and 2 you're going to get minus 10, and if you add minus 5 and 2 you're going to get the minus 3. So therefore we can factorize it in that way, and therefore that is the final answer, and these are the two brackets here, x minus 5 and x plus 2. Now, we've talked about this in the factorizing video in the algebraic expressions chapter. I would highly recommend going back to this for this tip, but I'll explain it quickly now. Is you can check whether this is the right answer by putting this cubic into your calculator using the equation slash func setting. If you put this cubic into the calculator, you will get out the solutions of x as minus 5 over 3, 5 and minus 2. And what is really good about this is you can check whether you've got the right answer, because from these you can find the brackets and the factors. You can find these brackets. So what you need to do is you need to take one of the numbers. I'm just going to take 5, and therefore there you do x is equal to 5, and then you rearrange this and put everything onto one side. So here you're just going to move 5 onto the other side to do x minus 5 is equal to 0. And this is what one of the brackets is going to be. And as you can see, this is one of the brackets here as well. You can do this for the minus 2 and the minus 5 over 3 as well. So for the minus 5 over 3, I'll do it over here. You do x is equal to minus 5 over 3, and then 3x is equal to minus 5. You times both sides by 3, and then it's going to be 3x plus 5 is equal to 0. And this is one of the brackets, and we've also got this over here as one of the brackets. This is a very useful way in order to check whether you've done it right using the calculator. I really recommend using this tip. It helped me a lot during my A level. Now, really quick, for this calculator method, again, more details, if you want more details on it, it's in the Factorising video in the Algebraic expressions chapter. You might be tempted to use this for the entire question. As obviously you can get the factors if you do the minus 2 as well. You can get all of the brackets here just by using the calculator. So why don't we just do this for the whole thing? Well, it's worth 5 marks, this question, and that is an indication that in order to get the marks you have to show a method. And the problem with the calculator method is that, to be honest, you can just do this in your head to the point where you're not actually going to be doing a method. You're just going to be subbing values into your calculator. And as it's for 5 marks, that indicates that they want some method marks, and they want the method marks through the algebraic division. If you do it just by using the calculator, you won't get any marks. However, the calculator is useful for checking that you've done the question right, because you can check whether the brackets are right. So use the calculator method for checking. Don't use it on its own for solving the question.